Problem number 10 out of 6.4 says there's 9 members of the Board of Trustees of a college, and 5 agree with the president on a certain issue. All right, let's get a count here. I'm just going to draw, let's say, a room. And what we have is that 5 agree, and since there's 9, that means 4, I'm going to write A prime, do not agree. So N is equal to 9. And then it says the president selects 3. So R is equal to 3. And we want to know what is the probability that at least 2 agree. Now, since we're drawing only 3 people here, at least 2 or 3, let's just do this directly. So how do we get at least 2 here? This could be the probability of getting 2 to agree or 3 to agree. And if we write these in terms of the pairs of everything we have up here, A's and A primes, I'm going to use a square bracket here. How do we get 2 to agree? Well, that could be 2 to agree and 1 not agree. Or we could get 3 to agree and 0 not to agree. And now we can make our count. So we're going to get out of 5 who agree, choose any of those 2, and out of the 4 who disagree, choose any 1. Or, out of the 5 who agree, choose any 3, and then out of the 4 who do not agree, choose none of those. And then it is a probability, so our denominator is going to be, out of those 9 trustees, choose any 3 of them. This is actually the mathematics. We've got our answer right there, and if we type it into the calculator, well, I got 5.5952 when I rounded to 4 decimal places. Problem number 18. An airport limousine has 4 passengers and stops at 6 different hotels. We want to know what is the probability that 2 or more people, and we want to know what is the probability that 2 or more people will be staying at the same hotel. Well, this idea of 2 or more, that's at least 2. At least 2 out of these 4 passengers will be staying at the same hotel. So I'm going to think opposite here. I'm going to think opposite. And the opposite of at least 2 staying at the same hotel is going to be, right, think opposite, 1 minus the probability that none of them stay at the same hotel. Now, the probability, just pick one of these people, the probability that that person chooses a hotel, that's 1. And I'm going to think of it like this. The first person can choose any one of 6 hotels. But now we want them to be different, so the second person can choose any one of 5 hotels. We want the third person now to be different than these 2, so any one of 4 hotels. And then the fourth person can choose any one of 3 hotels. And because it's a probability, we're going to have a fraction here, and the denominator is going to be the total number of ways that 4 people can choose the hotels. Well, the first person can choose any one of 6, the second any one of 6, the third any one of 6, and the fourth any one of 6. So we're going to have 1 minus 6 times 5 times 4 times 3, all over 6 to the 4th. And there's our solution, and if we insist on computing it out, we're going to get 0.7222 to 4 decimal places. Problem number 22 tells us that in a certain manufacturing process, the probability of a type 1 error is 0.12. That means in this process, 12% of the time we're going to get a type 1 error. Type 2 error is 0.22. And the probability of both of them occurring is 0.02. And what we're looking for here is the probability of neither. I'm going to draw a Venn diagram for this one. So here's our universal set. Here's type 1 error. Here's type 2 error. And we know how to fill this. We're going to fill it from the center out. So the probability of both errors is 0.02, and then the probability of a type 1 error is 0.12, right? The probability of a type 1 error is 0.12. We've already accounted for 0.02 of that, So in here, we're going to get 0.10, right? 0.10 plus 0.02 is the 0.12. And then probability of a type 2 error is 0.22. We've already counted for 0.02, so this is going to be a 0.20. Now outside here, in this region outside, this is going to be 1 minus all of this. So this is going to be a 12 and a 20 is a 0.32. And then what we're looking for here is that 1 minus 0.32, which is going to be 0.68. And we are asked, what is the probability of neither? Well, neither is this area out here, right? We don't want to be in any here, so it's going to be out here. So our solution to this problem is 0.68.